Hello Year 9s and welcome back to mathematics. In this video I'm going to go through the next section which looks at finding missing sides using trigonometry. Now let me just give a quick recap of what we did in the last lesson. Now in the last lesson we introduced the topic of trigonometry. Trigonometry was the study of three-angled shapes, and in particular we're looking at the relationship between the angles of the triangle and also the side length of the triangle. And here, the first thing that we did was we labelled our three sides of our right-angled triangle. The first thing was, when we labelled the sides of our right-angled triangle, we had three sides that we wanted to label. The first side was the hypotenuse, which is always opposite the right angle. So we look at the right angle and we go opposite, and that side length there is your hypotenuse, or we shorthand it to h. Then we look at where the angle is. So here we introduced the Greek letter theta to represent a missing or unknown angle. And here we've got theta, and the opposite side to the angle theta is this one over here, and we called it the opposite side because it's opposite theta. And the final side was the one that was right next to our theta, which was called the adjacent side, which just meant adjacent. Then from there we introduced the three trig ratios that we're going to use. Here we have sine theta, we have cos theta, and we also have tan theta. Now these three trig ratios give me a relationship between the sides of my triangle. So the first one was sine theta, which was opposite over the hypotenuse, so over h. And we used the shorthand so to remember that. So then we had cos, which was adjacent over hypotenuse, and we used a mnemonic or acronym CA to remember that. And the final one was tan, which was opposite over adjacent, where we use the acronym TOA to remember that. So we used these were the three trig ratios that gave me relationships between the three sides of my right angled triangle. Oh, the three sides and the angles in my right angled triangle. So what we're doing in this lesson is we're focusing on how we can actually use these three trig ratios over here to help me find missing sides. So in the past, when we looked at Pythagoras' theorem, we were able to find missing sides by using Pythagoras. Here, we're going to be able to use trigonometry to help me find the length of missing sides. Now, before we get started, I want to go through what these trig ratios do. Now, if you have a look, I have sine theta here. Now, theta is just an angle. It's an angle. And in year 7 and 8, you dealt with a few angles. You dealt with looking at angles between lines, the angles in shapes. Now, your angles, we use degrees to measure them most of the time. So when we see sine theta, or any of these trig ratios, this theta represents an angle. And we can put in any number for this angle. So for example, I could pick sine 20 degrees. Now, what I can do is, this will just give me a value. This will give me a number when I put get sine 20. So when I put 20 into my angle, sine 20 will just give me a number. And so on your calculator, if I can find my calculator, I'm going to get my calculator out. You have these three trig ratios on your calculator. So if you have a look on your calculator here, it's not very zoomed in, but hopefully you can see on your calculator you have sine, so sin, cos or cosine, cos, and tangent, all on your calculator here. So these three buttons represent those three trig ratios. So here, for example, I can put into my calculator sine 20 for 20 degrees, or 20, and you can even put in a little button here just if you wanted to do degrees. I don't need to do it for here. And that'll give me a value. So here, the value of sine 20 is 0.342. 0.342. And the digits keep going here. Now, the reason why this is actually important is because we're going to need to use this to help me find the missing length of sides. So let's actually get some practice of using these trig ratios and putting them into our calculator. So